Good afternoon. Good morning, everyone. My name is Derek Lawson, and I'm a product manager of process automation services here at Inflow Technology. And what I'll be doing today is showing you what exactly is DriveWorksXpress and how we can get started. So before we dive too far into it, we are using WebEx for our presentation medium today. Inside of WebEx, there is a Q&A panel, and there is also a chat panel. Although I'll be presenting today, I do have my colleague, Mr. Nick Skubis, helping with any Q&A or chat questions that you may have. So even though we'll be presenting relatively fast paced today, if you do have any questions at all, please feel free to paste them there, and then he could help with whatever he can. But at the end of the webinar, we will stick around for just a couple more minutes. If you do have any questions or anything that hasn't been able to get answered, we'll stick around for a little bit and make sure that we get all those questions addressed for you. So I think with that being said, let's go ahead and get started, right? So again, my name is Derek Lawson, and we'll be going through what is DriveWorksXpress and how do we actually get started with it. So to kick things off, what exactly is, who exactly is Inflow Technology, and, what do we do? So Inflow Technology is actually a subsidiary company of Computer-Aided Technology, or CATI. So with CATI, we are a value-added reseller for Dassault, so we deal with any of your design applications such as Solidworks, CAD, electrical, design automation, draft site, technical communication, simulation and analysis, 3D printers, hardware, scanners, and of course, PDM and PLM systems such as SolidWorks PDM, Manage, Innovia, and of course, DriveWorks. And that is where Inflow Technology really brings value to that market, because what we focus on is data management and those services, making sure that our customers have the best information that they possibly can. So with all these different solutions that we offer, again, what we're going to be focusing on today is the DriveWorks platform, specifically DriveWorksXpress. So it's a very easy to use design automation choice for SolidWorks. Now, DriveWorksXpress is actually part of a 3-platform product. So DriveWorksXpress is the smaller free application that's included in every SolidWorks license that you have. So typically, whenever we start on our automation journey, we like to try out Express for free. And then as we continue to build the products that we have, we can move up to another product called DriveWorks Solo, which has a little bit better user interface and design and a lot more options that we can work with inside there. This actually comes with a 30-day free trial to make sure that it is the right fit for you before making any purchases. And then beyond that, we have DriveWorks Pro, which is, of course, the large-scale version that allows for, web designs and, advanced automation and drones being set up and all types of really cool stuff. But that's much further down the road. What we're, again, going to focus on here is DriveWorksXpress. So as I mentioned before, DriveWorksXpress is included in every seat of SolidWorks. And the way that we work with it is we essentially open up SolidWorks, we fill out a form, that form passes that information into the models and assemblies and drawings that we've captured and generates those new files for you really, really quickly based on your inputs. So it allows you to make, as you can see here in this image down below, various different types of the same product. Be it a little bit wider, additional configurations, things like that, really quickly without having to deal with tens, if not hundreds of configurations or, any type of design sheets or design forms or something like that inside of Excel. We could do it all within the application itself. So their motto is really, DriveWorks is good for anything that's the same yet different. So Express is a really good way to kind of get that information kicked off. So the way that we'll be working through this, and I'll actually be going through a live demonstration today and showing you how it all works on the back end, is the way that we work through it all is we set up a form inside of DriveWorks Express inside of Solidworks. These forms are customized, putting in the information that you know you'll need to drive that product. We simply fill out the information that's required. Using that information, it's passed into the different models or assemblies that we've captured as well to update things like the names or dimensions or properties and things like that to make that essentially a brand new part, but modified from the original version. Once that's completed, we can get our resulting assemblies, resulting part files, and even the drawings that we have associated with those models as well. So again, it kind of gives us a really quick, complete picture of something brand new, but similar to what we already had. So as we continue to go down, we can create these files again and again and again, making sure that we have consistent designs and saving us a lot of time on the back end because we don't have to go through and do like a pack and go and then pull all the information and then go back into the models and modify the dimensions and do all this stuff. We can just run this project over and over and over again and get these different components and assemblies. So how exactly do we get started with DriveWorks Express? What do we have to do to get this thing kicked off? Well, we first have to set up a project in DriveWorks Express, and that's going through and doing what we call a capture on dimensions, features, components, models, anything that you know is going to be changed inside of this design. We want to make sure that's captured. Then we go in and create our input forms that allow us to manipulate that data. And then we can assign and build our rules to drive those captured components based on our input forms. Once we have that project set up, then we can simply reopen that project anytime that we need, run it, and get that new product being generated every time. So in order to first start this up, you will have to register DriveWorks Express inside of SolidWorks. So you can actually go to mysolidworks.com and input your serial number there, and you could see the new code that it will give you. Or you can go to the driveworks.co.uk/product/DriveWorksExpress, and that will take you to a link there. But by far the easiest way is by simply kicking off DriveWorks Express from within SolidWorks directly. So the way that we do this is inside of SolidWorks. If we go to Tools, Express Products, DriveWorks Express, it will pop up that activation window for you. So I've actually stolen a little video here from DriveWorks directly showing how this is all set because they did a pretty good job making it work. There we go. And plus mine's already activated, so this will work a little bit better for us. But we can see here in SolidWorks, you can go up to the top under Tools, Express Products, and DriveWorks Express, and it will pop up this window here asking for a product code. From there, we can click on the provided link to go to mysolidworks.com/express, and it'll actually prompt you to log in. I'm going to skip over this part just a little bit because we don't need to see it. But once we log in, it actually gathers all your information for you, your serial number, what you're looking for, and provides you with that code right there that you can then copy and paste into the product code slot. And then, of course, once you click OK, DriveWorks Express is now activated inside of SolidWorks. And we can go in and can continue creating our databases and projects and everything else that we need to do. So it's a really simple process to get everything started. Once you have DriveWorks Express activated inside of SolidWorks, now you can start putting that project together. But one of the big things that we kind of want to figure out is, what is that project going to be? Now, a lot of our customers like to think big. We're engineers, we're designers. We like to see that big picture and continue growing it. But this is really just a tool for us to do our jobs, right? So one of the good metaphors that I like to use with this is, if you're building a house, what we want to do is we want to take your 16-ounce framing hammer or whatever you're using and replace it with a better tool. In this case, a pneumatic framing nailer, right? So it's not really doing the whole build for you, but it's making your job a lot easier. So instead of trying to build the entire house, let's focus on something a little bit smaller that's going to make your job easier and these processes go quicker. So in this case, we could focus on designing just the machine guard for a whole assembly like this. Maybe not the factories itself, but the machine guards that can go around it. What I'll actually be looking at today is instead of designing a whole house, I'll actually be designing just the walls themselves. Because of course, when you're putting a house together, the walls are big parts of it. They're all going to be different lengths. They could have different features inside of them, things like that. And it takes a long time to copy and paste this information out, modify the amount of information and the components that go inside there. I want to make it easy on myself and just say, here's the wall that I need. Let's go ahead and make one that's 10 foot or 12 foot or 14 or whatever length we actually require, and give me a drawing for that. So with that being said, what I'll do is let me go ahead and open up SolidWorks here and kick off SolidWorks DriveWorksXpress inside of this. So as you can see, mine's already been activated. So when I click on this, it will simply open up DriveWorksXpress for me. So what I'm going to do is I'm actually going to go through and create a project from scratch, just so you could see the entire process and what we're looking at. So of course, the first thing that I need to do is to create a new database that's going to hold all this information that I'm working with. So I've got some source files that I know I'm going to use. We're going to call it wall framing. So that's why I'm going to call my database. And you can see it's going to create a Microsoft Access Files database here. Now, once I have that database generated, it's going to ask me, what's the product that I want to create this project from? So what are the SolidWorks models that I'm using? Well, again, I already have those kind of figured out. Under my source files, I have a wall template that I'm utilizing here. So when I select that, it's going to open that file up. And just a little pro tip here, whenever you start capturing something with DriveWorks, I like to do a Control Q. You can't see me do it on my keyboard, but I'm doing a Control Q to do a full rebuild, and then fit it and save it. And that makes sure that everything is nice and clean. I don't run into any weird programming issues because something wasn't fully resolved. A Control Q really helps fix that when you first start capturing your information. So when I look at this wall template that I have set up, I put some pretty good design practices in there already. So I've got some planes inside here that I use for my design, for like the wall center lines, the floors, where the wall is going to start. I've also got some references for where the ceiling joist is, or the wall end and the wall middle. So just by having this set up, I can always come in and adjust my wall length by modifying this dimension here and saying, well, I want to make this 200 inches now. But you can see I run into some issues. It's still not perfect. I do have a pretty smart patterning component for my studs, just because I do have a stud pattern that's going all the way up to my reference of the wall end. So that's pretty clever. But I don't have my last top plate and my last sole plate extending out to where I need. Now, I can open those up and modify the dimensions every time, but again, I want to use DriveWorksXpress to make that a little bit more simpler for me, right? So what I'll do is I'll go ahead and just pull this back to the standard 120 here. So what I'm going to do is I'm going to make sure to capture this information that I'm changing. So inside of my top level assembly, I can capture different models in the assembly structure, so I could see all my components. I could capture dimensions, features, custom properties, and drawings as well. So I'll actually, since I'm here, I'll go through and pull in the drawing that's associated with this template, so that every time I create a new length, it will give me a new drawing that uses that component inside there automatically. So now I can see that that drawing is captured. Now, what I know I need to change, just like I've done before, is I need to change that dimension that tells me what the length of my wall is going to be. So this dimension here, if I select it inside the graphics interface, I've actually called this dimension wall length. which means that name is going to transfer over to my DriveWorksXpress capture window and say, well, we'll capture this dimension as wall length. So now I can start passing information to it. But what I also want to do is I want to update the lengths of these two components. So right now, the only assembly that I've captured is the wall template because that's all I'm changing, but I also need to change these two components too. And in order to change those, I do need to capture them. And that's as simple as simply checking the boxes next to those two components. So now that they're captured, I can open those parts up and do the same thing with their dimensions like I did with this assembly. So inside of this piece of wood, I can grab the total length dimension, which I've already called length, and I can choose to capture this dimension inside of this component as length. I'm going to do the same thing with the top plate because I want to make sure that both of those are being updated to the correct length. All right. So now, if I go back to my project, I can see that I have those dimensions captured. I have the models captured. I have all the stuff that I know is going to change captured. What I need to do next is I need to move from our capture tab over to the form tab. So this form tab is actually what tells you the interface that you're going to be able to utilize. So you can simply click add here and choose from a couple different options of user interface controls. We have text boxes, numeric text boxes, drop down spin buttons, and check boxes. So in this case, I'm going to use a text box, and this control is just going to be called name because that's what I want to name this assembly. Let me make sure that's correct. And I'm going to require this field to be filled out. I'm also going to create two more controls. This one is going to be a length in feet, and that is going to be a numeric text box. And I'm not going to require this one just because I may want to input everything in inches and not feet, or vice versa. But I do want to apply a minimum value, which could be 0, and a maximum value of, let's just say, 16. So I can't go any higher than that or lower than that, maximizing me at a 16-foot wall. I also want to add another control for the length in inches. This again will be a numeric text box. I won't require it. The minimum could be 0 because I could have an 8-foot 0 wall. And the maximum value is going to be 192 because if I did want to put my length in inches, I could go up to 16 feet. So now that I have my controls set, I can actually see what this interface is going to look like by testing this and typing some information in, seeing that I do have limits there, and really kind of seeing how that will work from an interface side. I could also choose to set my defaults to those values too in my tests. But in this case, I'm pretty happy with what I've got. What I'm going to do is I'm now going to bridge the information that I've captured inside my assemblies and parts with the information that I've placed here. So to do that, I go over to my Rules tab. And what I can see here is I could see any file names, configurations, custom properties, dimensions, or features that I've captured previously. And it's actually going to tell me how many I have and how many don't have a rule currently assigned to them. So the first thing that I want to do is I want to change these files' names so when I save the files, they're going to be named something appropriate. So if I choose to edit that and then edit those rules, I can see all the components that still need a name assigned to them. So the first thing that I'm going to do is I'm going to put a name to this wall template assembly by selecting it and choosing build. From here, I can use pretty much any Microsoft Excel function or syntax that's out there because DriveWorks was actually built off of Excel, which is really cool because a lot of this stuff is going to work in this scenario too. So when I'm looking at this rule builder, I have the ability to see any input that I've added. I can see any recent things that I've saved, which I'll show you here in just a little bit. We have mathematical equations that could be used, and we have different logic that could be used as well, such as greater than, less than, nots, or ands, and if conditions. So these are really helpful, and we'll see how these work a little bit later too. But what I want to define is a name for this assembly. And that name is going to be pulled from my name input that I just added there. So if I just left this as name, the new assembly that's created will actually be called wall template and then whatever I called that name. I don't want wall template to be part of the new file name. So a little trick is we can actually add an asterisk in quotes and connect those together with an ampersand, and this asterisk will actually clear the previous name. So the new file will only be whatever I've inputted into the name control. So now that I have that rule set, I want to set names for the last sole plate and the last top plate also. And these are actually going to be the same, so I can click on both of those using the control key and build both of those at the same time. Now, in this case, I'm going to make my rule a little bit different. I want to call these the last sole plate dash whatever my total wall length is. So I'm actually going to build a little rule for that. So it's going to keep the last sole plate, but after last sole plate, I want to put in a space dash space as text. And then I want to connect that with something else. And in this case, I'm going to use some math and some logic here. So what I'm going to do is I'm actually going to take whatever the user inputs as my feet length times 12, because I actually want to convert whatever they put as a foot length to inches. So if they put 2 foot, it's actually going to be 24 inches. Because if you remember when I modified this, it was all in inches. Then I want to take whatever they added to the inch column as well. So if they say it's 2 feet 6 inches, I'm going to pull all that together. So now I have 24 inches plus 6 inches, giving me a 30-inch length wall. So when these files are named, they're going to be called last sole plate space dash space 30 inches. Same thing with the last top plate. So we can use these controls to really build some good logic inside of what it is that we're doing here. All right, so I have those names set. And if I go back to the summary, I could see that I have all the files with none missing. I now want to go in and modify the dimensions that I've captured for all those too. So if I choose my edit checkbox there and choose to edit those rules, I can see the dimensions that I've captured inside of the wall template, the 2 plate parts, and then what I've called those dimensions as well. So the first thing is this wall length inside the wall template assembly, that whole dimension that I can modify there. So what I want to do is I want to make it the same thing that I've put in before. But what I've done, what I didn't show you, is that inside of this recent list, you can actually store quick text. So what I've done is I've actually added that little equation that I used before, length foot times 12 plus the length inch, as something I can reuse over and over and over again. So almost like storing it as a variable, which is really cool. So this dimension is simply going to use that equation to drive what the overall length of this wall should be. And now I'm going to do something very similar for both these plates. To calculate what that length should be, I need to know what the overall length of the wall will be minus whatever the default value is for these stock boards, which I know is 96 inches. So what I'll do here is I'll come in and I'll use the same function of give me the overall length of the wall itself, and I'm going to separate this so it calculates properly. So please excuse my dear Aunt Sally and hit those parentheses first. So once I get the total length of the wall, I'm going to subtract that 96 inches that is this board here. So the total length minus this board will give us the required length for these 2 boards here. All right, so now that I have all of that information set up inside there, nothing is missing, I can actually run this program. I can run this application. This project is good to go. So if I hit this play button, I can see the form that I've put together. And I'll type in something really basic. I'll call this one wall 1. I'll give it a length of 10 feet and 2 inches, right? So now I'll have a 10-foot 2 wall that I want to generate here. So once everything is set the way I like it, I can hit this create button, and it's going to come through and start building all that information. So I can see that it's putting together, I think that might be pretty close to what I already have. I can see that it's building a wall framing called the total wall length. It's going into these components here, setting those lengths to the appropriate length. So the last sole plate and the last top plate, and setting those to a 26-inch length. So that way we know it's filling the gap. It's also going through and updating my drawing. So I could see that it's now a 10-foot 2 wall, and everything is being built properly. So that really wasn't a whole lot of a difference. So let's create something else really quick. So already I have this 10-foot 2 wall. Let's create, let's just say wall number 2, and let's make that a 14-foot 2-inch wall. So if I choose to create that, I could see that it's building a new file 170, changing the dimensions inside there and applying those to the appropriate top level assembly. So we can see Express actually going in, opening the models, applying those dimensions, coming back to that top level assembly, doing the rebuilds, and you can see it all updating here, and creating the appropriate drawing, as we could see here, to make sure that all those dimensions and everything are set up correctly. So I can see my 14.2, the other dimensions are still the same, the drawing is correct, it's now wall 2, and I have those walls built very, very quickly. So again, I don't have to go through and build the entire house. I can build it one component at a time, going back in and building these walls over and over and over again, saving me that time of simply, doing a pack and go, grabbing the files, making sure they're different names, going back into each component individually, updating the dimensions, making sure the references are correct, rebuilding the drawing. All that was done within just a matter of seconds using something like DriveWorksXpress. So now, if I know all the wall lengths that I need, I can just fire all of those off in rapid succession, and now I have all the wall subassemblies that I can utilize and put them inside of the total floor plan that will comprise the entire house. So pretty cool stuff here. And of course, as we continue to go through, it gives us a really nice report as to what's going on to make sure that everything is set properly. So another way that we could utilize this, and you know what, I'll do an edit here. So if I make a third wall, and say this one isn't longer than the original, say this one is 7 feet long. Well, what's going to happen there? So if I choose to create that 7-foot long wall, it's obviously less than the original board that we had. So it's having trouble running through and doing those calculations. It's trying to make a board with a negative value. And of course, we can't have negative board. We need something positive to go in there. So at this point, we're going to see some errors popping up inside of our report saying that these dimensions could not be driven. And we're going to see some errors inside of the models themselves. So as we go here, we could see that these original boards are still there, and the last sole plate and the last top plate didn't update. They errored out. So, there's some issues there. But what we can really use with DriveWorksXpress, what we could really utilize inside here are those Excel equations and those Excel functions that we wouldn't maybe typically have access to. So what we can do, and I'll go ahead and finish this, and we'll cancel this one out, is let's modify the project that we currently have. So, and I'll close this guy because we know we don't need it. And let's take a look at some of the other files that we're working with. So when an error like that pops up, what do we need to do? We need to suppress these two boards because they're not necessarily needed, and make sure that these boards are of the appropriate length. If it's a negative, how's that going to work? So we may have to come up with a little bit more of an advanced equation to make that happen, but that's really not so much of an issue. So if we go back to our capture, now we need to change something with these two boards. We need to make sure those boards are captured too. So if we go to our captured assembly structure, we can choose our standard top plate and our standard sole plate and start modifying the information that goes with those. Now, at that point, we don't really have to modify anything with our form. There's nothing changing there, but we do have to modify some of these rules. So you can see with the file name, since I added those two components, there's still two missing. So what I want to do in a case like this is for both of these components, I want to put in a special rule that says that if my total wall length, and again, I'm going to separate this to make sure that it's all correct, but if that total wall length comes in at a lower value than the standard 8 feet or the 96 inches, then these two components need to be suppressed. Otherwise, keep them there. And I can do that with my if logic. So I'll go ahead and use the logic button just for clarity's sake. So if I say if that total wall length is less than 96, then what am I going to name this file? And instead of a name, I can actually use a status. So if that is all less than 96, then I want to suppress this file. If it's not less than 96, then I'll simply say unsuppress this file. So of course, if I come up with a less than 8-foot wall, it will suppress that. Otherwise, it'll keep it there. Now we have to do the same thing with our dimensions, because if those two are gone now, we need to make sure that these are spanning the appropriate length and not trying to put in a negative value. So what we can do there is with these dimensions for those two components, we see they have the old dimensions sitting inside there. We simply have to modify those. So if I select both of them and choose build, instead of saying, minus 96, we may have to do something a little bit more in depth. So instead of 96, say in this project, we could have it extremely long and we have multiple boards inside there. Well, we want to kind of future-proof this by setting up a better rule for it. So what we want to do is we want to see how many of these standard length boards can fit inside the total length wall. So we can use our math conditions there in the recents and say, well, let's take our total length and divide that by 96, because that's the default length of this board. So if we take that total length and divide it by 96, it'll come out to 1.2 or 0.8 or something like that, just because that's how the math works. So we can take that and realize how many of these boards are required by, again, rounding that, because we won't necessarily want to use 1/8 of a board. We want to see how many boards are actually used in whole. So we can pull in another option in here, and I actually want to add some additional parentheses to make sure this is all calculating correctly. But we can add another Excel function, and this one is the standard round down. So if I take this equation, the total overall length of the wall divided by 96, say that comes out to 1.2 boards, I want to round that down to the nearest whole value. So that will tell me that there's just one board inside there. If that total length divided by 96 was 2.75, it would round it down and say there are 2 full boards inside there. So now that I know there's X amount of boards inside here, I want to multiply those by the default length of 96, because I want to deal in inches. So 2 times that 96 will give me the full length of how many total boards I have at the beginning in inches. So it's a little bit more of a complex equation to make this happen, but it really utilizes a lot of cool things that we can do just like we would inside of Excel. Things like the round downs and the nested statements and multiplications and all that fun stuff could be used inside here too. So with those being set, let's just click OK here. With those new dimensions being set, let's try running this project again, and hopefully it works. We'll see how it goes. But if I run this project, and let's just say this is wall 10 because I forgot what I had left off on, and the length we'll just say is 4 feet, 1 inch. And if I create that, let's see how it works this time around. Because what it should be doing is, because it's less than 8 inches, those two components should be unsuppressed, while these two components are going to make up the value of essentially the total wall, because it's going to calculate that there's 0 main boards to begin with. So it's going to suppress those out and have these two fill that gap, which hopefully it's working pretty well. All right, so it looks like it's okay. There may be an additional stud. I might be right on that line for some calculations there. But you can see that it is going through and suppressing those original sole plates and those original top plates, and then making up for that total wall length of what we have there. And let's see, I'll bump this up just a little bit more. Let's just say a 6-foot wall, 6 foot even, and see how that works. And of course, I need to give this a new name for it to be regenerated. And we could see that we can shoot off these walls relatively quickly, giving it new information, resizing all these relatively quickly without us having to do any manual intervention, and it gives us exactly what we want. So this is a really good way to start your projects and get some basic information pushed out really, really quickly, and you can go about your day and doing the things that you were actually trained to do, such as designing and engineering, and not worrying about finding an appropriate assembly to work with and renaming all those files and adjusting them. You can focus on the hard stuff, which is the design and engineering and what you actually entered this industry to do. So it kind of takes some of those mundane tasks out of your wheelhouse and pushes them to the program and the tool that's designed to do something like this. So again, really cool how we could take something so simple and build them over and over again to be applied to something much larger in the future. And Luke, looks like you had a question. Let's see, what do we got here? So the question you asked was, right now you're building up the logic for a single wall. What if I was trying to input a whole home into DriveWorks? Would it be best to go wall by wall, subassembly by subassembly, or input the whole house at once into DriveWorks? And that's a really good question. It does kind of span outside of DriveWorksXpress, but it kind of depends on how your design is and how you want to convey that information to the designer. So eventually you're going to have to do it wall by wall. It's just, how do you start when you first put the design together? So you could take the standard kind of CAD operation where you start a line, draw where the line is going to end, and there's your wall. And then from the end of that line, you draw another point, and there's your second line, and you go from there. So you could do it that way, wall by wall, plugging those in, or depending on how the user wants to interface with it, you could have something that just says, start with a shape. Here's a rectangle, add more rectangles on there, and then gather a perimeter inside of that. So that could actually take, your XYZ points and say, well, here's all the different points to it. Let's try and connect those. It may take a little bit more automation and equations and logic on the back end, but it really boils down to the user experience. Me personally, I like the wall by wall method because the walls could change in and of themselves, and you don't want to have to modify everything to begin with. Each wall could be very custom. So I personally like to do it wall by wall. Another question coming up, does this create only new assembly files, or can we create new configurations in the same assembly file also using DriveWorks? So with DriveWorksXpress, we have the ability to switch configurations. So for instance, I actually have a door frame. This is for one of my larger DriveWorks Pro projects. But inside that door frame, I actually have multiple configurations where I can say, we'll go with a 30-inch interior door, 34, 36, large closet, something like that. DriveWorksXpress, if I chose to put this in here, I could have it change to any one of these configurations. Unfortunately, it will not create a new configuration. Something like that would have to be for, a larger DriveWorks product like DriveWorks Pro to create the new configuration for us. But again, a little bit of a pro tip is, we want to make our drawings and files as small as possible. Maybe creating new configurations isn't the best way. Maybe we could get away with creating just a new assembly and not having a large file with 47 configurations that need to get loaded every time you open it. So it could be done in the higher versions of DriveWorks, but just because we could doesn't necessarily mean that we should. So that would be a consideration that you want to look at as well. All right, so we have a third question. For a single part with dozens of configurations, is there a benefit of DriveWorks over, say, design tables? And that's a fantastic question. So again, we start getting into how big are these files going to be? So design tables are a really good substitute for what we're doing here. And if you really boil it down, it's kind of the same concept, right? So you have this information that you're plugging into a new row, or you re-push back into the product as a new configuration, and that's perfectly fine. It just depends on what your intent is. If the files or designs are going to have a handful or dozens of configurations, you're probably okay with keeping it as is. But the problem becomes when you start growing and expanding. And now a simple gusset file or something like that, that's probably too simple of an example, but maybe a frame, a door frame, now has 57 configurations in it, and those configurations may have sub-configurations inside there, depending on where the hinges are or the swing of the door or something like that. Now, anytime you open up that door, it has to load all those configurations first. So the biggest distinguishing factor in probably all that, design tables and configurations, is just the sizing. How long do you really want it to load? And do you need one file with multiple configurations inside there? Or do you want to really keep it project specific, where this file is used for this project, and there's no fear of updating a configuration at the source and having it somehow mess up other things in other places? So again, a lot of it depends on what you want to do, but there's no wrong answer, so to speak. All right, and the last question so far. This is great, but you skipped over the very first step by saying that you have the support files already created. When I select create or change database, it's looking for a Microsoft Access file, right? It seems like that would be an important thing to have when you start. How do these templates get generated? Yeah, so that is one thing that I did go through and do, and I can run through it really, really quick here. Inside of Tools, Express Products, DriveWorksXpress, I already have one created. So you can actually choose to create a new database or change your database if you had one opened already. Or you could add projects to your existing database or just run the projects themselves. What I'll do real quick is I'll show my source files and what's been created on the back end. This actually created an MDB file. What I'm going to do is I'm going to get a little bit squirrely because, well, why not? I think we'll be okay. So what I'm going to do is I'm going to close out of all these. Maybe. It's taking a while because I have a lot of files open. But while that's waiting, when you first run DriveWorksXpress, this is really the only option that you have. And it's going to prompt you essentially for a location as to where you would like to save that database. So when I first started, the only files that I had inside here were these two. And I simply said, select this folder and create a new database called wall framing. And yeah, I may have killed my Solidworks jumping back and forth with different things. That's what I get for trying to be squirrely there. All right, so another question here. Can you save out all the files in the template with new names, even if you might not modify some of them? So that's a really good question. Whenever we go through, I may just kill SolidWorks altogether here. Let me pop that up. So what happens when we go through and generate all these files is if the file is already in use, oh, there we go. Now it's popping stuff up. I won't have to kill it. If the files are already in use, it's going to try and use those. So if those files are not in use, it will give it a new name. So if I created another 10'2" wall or something like that, and it saw that this file of last top plate 122 already existed, it's going to try and use that source file of last top plate 122 and place it inside here. However, when we capture files inside of our project, we really only want to capture files that we know we're going to change. So if I look at my wall template, the entire assembly structure has these top plates and sole plates and everything else, but I'm not changing the studs themselves. Those aren't changing at all. I'm not changing the door frames. Therefore, I'm not even capturing those. So it's always going to use the same stud file that I had in the source file inside of the new assemblies, kind of like a pack and go does. Um, so it will keep those the same. However, anything that I did capture, it is going to try and copy out with a new name unless I already created that same name in a previous project. Then it will try and reuse that already existing file name if it matches. So a lot of it is driven off the file names that we're using there. Okay, and we have another follow-up question here. Due to our workflow, I need a separate file. Let me make sure I'm reading that right. Due to our workflow, I need a separate file for each time I run my project. That is perfectly okay. With what you can do inside of DriveWorksXpress is you could choose to capture these additional files. And then the only rule that you need to change is the naming rule. So at that point, you could just say use the additional name that already exists for that template file, and then add on with the name that you type inside of your input. So now it's a unique file every time you do it. The only thing you're doing is changing that file out with a brand new name that's used inside of this brand new assembly. All right, so another question from Luke here. How does DriveWorks do with changing weldment sizes? It depends on what you mean by weldment. So are we talking like weldment profiles, or are we talking like an actual weldment part inside of Solidworks? It does work, not so much with Express as it does with DriveWorks Professional, because it does have the weldment portions built in, so you have a lot more control over it. But if it's very simple weldment, you could still modify the sketch dimensions, and the weldment by default will update to match those sketches. So if it's very simple, it's something that you could do inside of DriveWorksXpress. But if you start changing out the different weldment types, you may need a higher level of DriveWorks. Okay, and just real quick, I'll run through, since SolidWorks isn't slowing down on me, how we would go through and create that new database. So if I had just activated DriveWorks and I need to start a project, the only option I would have here is to create or change a database. What you could do is create that new database name here, just type that in and choose open. And if you didn't select one, it should create that for you. So that's how that database is created whenever you need to create a new one there. Or of course, you can simply select an existing one to switch it out. All right. Is the template made with SolidWorks or Access? I think I may be a little confused on that question. The template itself, like what I'm using here, is obviously made with SolidWorks. You know, I built this like I would any other SolidWorks assembly that I would work on. But the MDB file that Access would generate is just generated by DriveWorksXpress. So there's a little bit behind the scenes that it does. You know, it has a template database that it copies out and saves as an MDB file, and then continues putting information inside there. So based on the question there, it's kind of created by SolidWorks because SolidWorks is hosting DriveWorksXpress. So the MBD is created by SolidWorks. Just to kind of bring us to the tail end of this. So again, we saw how walls could be created, both the models and the drawings. You don't necessarily have to start off blind. There are a lot of sample projects that you can access from driveworks.co.uk. So there's a good amount of information. If you go to DriveWorksXpress, you're going to have some good samples there, some good educational information, even certification is available at that website. But there's also a lot of other locations that you can go to, such as cati.com. And then we have some driveworks.co.uk products, DriveWorks Express. DriveWorks Live is a really good location to see more advanced projects. Okay, well, I think if we're good, thank you all very much. I appreciate taking your time out of your day to watch me present a little bit on DriveWorks Express. I really appreciate it, and hope that you learned a little bit for it. So again, thank you all very much, and enjoy the rest of your day.